Hello, welcome to this episode of Why Love Geography. Today we're looking at the Geography GCSE AQA course about the physical geography section of climate change within the natural hazards section. We'll be looking at the causes of climate change, both human and natural, looking at the effects of climate change upon people and the environment, and also looking at how to mitigate and maybe adapt to climate change effects. Here's a range of images that you'll see throughout this presentation that will summarise the whole topic in the tab or the absolute basics section. You might want to pause at this point and see if you can remember what the images were for each one of those sections. So the boxes are exactly the same. It's got the headings on this one, whereas the previous one had the images on. Here's the tab Geography, the absolute basics about this topic. So you can see, during the Quaternary period, the last 2.6 million years, the Earth has gradually become a little bit warmer. Also, the temperature has fluctuated, and there's been rapid increases in temperature over the last 100 years. Now, the rest of these sections, we're going to go into more detail in the rest of this presentation, but pause here if you want to have a quick scan through. Here's some questions about the tab Geography on the previous image. So pause here if you want to have a go at the questions and just test your understanding. Here's the tab Geography, but with the information taken off. So what can you remember of what goes in these boxes? Feel free to go back and just check your knowledge. Can you draw a mind map of the information that you have just seen? So there's no stimulus materials for you. You've got your own headings. Can you put those on? Can you remember everything? If not, feel free to go back and check your information and add in anything that you have missed. It is pretty well accepted that climate change is happening. So there's global warming that is happening. Now, in the same way, in cold winter months, a greenhouse absorbs the sun's rays and keeps the heat within the greenhouse, and the glass acts as a barrier for the escaping heat. So in greenhouses, it's always going a little bit warmer, even in winter. Now, that same kind of process on the right-hand side image, a very simplified version of the greenhouse effect. So the sun's rays go through the atmosphere, they hit the Earth's surface, and then they bounce some of them back out to space. Now, if there's more particles in the atmosphere, some of the sun's rays can't bounce back out into space. So it acts like the glass in the greenhouse. So it keeps some of the heat within the atmosphere. Here we're looking at the Quaternary period in the age of the Earth. And there's lots of different ages. Probably one of the most famous ones in blue at the bottom there is the Jurassic period. So clearly that's when lots of dinosaurs are about, and that promoted the film Jurassic Park. Now, the period that we're looking at is the Quaternary period, and it's that tiny little red box with the red arrow next to it. So you can see how small that period is in the age of the Earth, maybe 4.6 billion years, the age of the Earth. Now, the Quaternary period is about 2.6 million years. Now, that sounds a long time, but you can see in relation to the age of the Earth, it's not a long time at all. The Quaternary period is probably around about the times when humans start to develop and evolve into what we see today. And you've got the graph above. Now, the graph above shows there's been massive fluctuations or changes in temperature over the last 2.6 million years. Now, clearly, some of that time we have influenced as humans, and some of that time, 2.6 million years ago, there's been very little human influence. Now, on graph B, it's zoned in a little bit, and that's only over the last 400,000 years. So pause here, have a quick look at that graph, and see about the fluctuations that you've got. Where the Earth is a little bit warmer, those are what's called interglacials, and where the Earth is a little bit colder, they're called glacials. So you'll know in the past that there was more ice on the planet, and in some points there was less ice on the planet. And graph C, we've got some information there, and that shows us the last kind of 120 years. And gradually we can see that the temperature has increased very gradually over the last 120 years. So that's zoomed in again. So how do we know what the temperature or the climate was like in the past? The first one here is direct instrument readings. So very simply, look at the thermometer, take a reading and record it. Now, of course, the problem with this is reliable thermometers have not been around an awful long time, maybe 100, 200 years in some form or another. Now, on the left hand side there, you've got a kind of technical weather station, so that takes all kinds of readings about the temperature, the rainfall, humidity and the wind speed, and they can be recorded electronically. But real serious electronic readings of the weather have not been taking place an awful long period of time, maybe 50, 60, 70, 80 years. Another way to track climate change is to look at tree rings. Now, it's well acknowledged that you can track the age of a tree by counting the number of rings, and that will tell you how old the tree was. It shows you each year of growth. However, also, if you look at the top right image, you can see that column A, so ring A there, that has had quite wide growth. So it will have been warmer, it will have been a little bit wetter, so ideal conditions for a tree to grow a little bit more. Whereas on B, you can see it's a little bit narrower. So that's probably cold and wet climate. So it doesn't tell you exactly the climate, but tied in with other evidence, it kind of backs up people's hypotheses or prediction about what the climate used to be. Now, clearly, you don't want to be chopping a tree down each time that you want to track the climate change. So you can take a core out of the tree, a little bit like an apple core. So that tree auger or tree core on the bottom left, that screws into the tree, and then on the bottom right, you can see out of that, the hollow tube in the middle comes the core of the tree. And it doesn't damage the tree too much, and you can track and use a range of different trees to see what the climate was like in the past. Another very similar technique as tree cores is ice cores. So in some parts of the planet, ice builds up and it doesn't melt. So Antarctica, for example, the South Pole. So you can see on the left-hand side, there's an ice corer. Sometimes it's done by hand, sometimes by a machine. I can go many kilometers down and get the ice out. And you can clearly see that the ice that's further down, that's older ice. And then at that point, when it's still frozen, you can segment it and chop it up, and then that releases whatever gases were trapped in the ice whenever the snow fell. Now, if there's more CO2, carbon dioxide, that shows the temperature was a little bit warmer. If there's more O2 or oxygen, that shows the temperature was a little bit colder on the Earth. Now, clearly this doesn't show you day-to-day temperatures, it gives you a rough approximation over a large period of time. So these are ice cores. Another very similar technique is one called pollen analysis. So those two people there have a peat corer. So that goes through a layer of peat. Now, peat is organic matter that builds up over time, and it's just a soggy, damp, dank environment, and it doesn't really decompose. So whenever the pollen in the air is deposited and then grass grows over it, that gets preserved. So the further down you go, you can see what the pollen was like maybe 1,000 years ago, 10,000 years ago, even 50,000 years ago, the further down you go. And through various techniques, you can extract the pollen. And then looking at the types of pollen that you see, you'll see the different types of trees and bushes. And if there's more of a certain type of tree, you'll go, that was a very warm year. If there was more of another type of tree or grass, you go, that was probably quite a cold year, because we know at this point on our planet, then those grasses grow in cold environments. So pollen analysis is another one. Again, it doesn't tell you day to day what the temperature was, but combined with other sources of evidence, it backs up the whole picture of tracking what the climate was like in the past. We're now looking at the human causes of climate change. This is what people have done, and it's thought to contribute to climate change. Now, the primary one is burning of fossil fuels. So these are organic materials that many million years ago were in the earth. They got compressed and then formed various compounds. So coal is one. That's seen as quite actually dirty fossil fuel. So not just CO2 is released, all kinds of other compounds released into the atmosphere. There's natural gas, and of course there's oil. And derived from oil is things like petrol, and lots of plastics are made out of the derivatives of oil as well. So these are some of the main causes of climate change in terms of human contribution. Another human cause of climate change is agriculture, and we're going to look at cattle ranching in this instance. So huge parts of the Amazon rainforest are chopped down so that cattle ranching can take place. Now, cattle ranching, we're not just thinking about a few hundred cows that we often see on UK farms. We're thinking about tens of thousands of cows for meat production for South America and then to North America and other places in the world. This is a huge export for Brazil. So it makes an awful lot of money. Now, when cows are on the land, the first thing that happens is you do not have the trees, so that does not take in the carbon. And when the cows are on the land, when they're chewing the grass and they're feeding, they're giving out gases, often methane, and that is 25 times worse than CO2 as a greenhouse gas. So it's not as common, but what there is of it, what the cows are giving out, is 25 times worse. Deforestation, or chopping down the rainforest, is a huge cause of climate change as well, because it reduces the amount of CO2 that can be taken out of the atmosphere. Added to that, a compound effect is the cattle ranching that you saw on the previous slide. So not only have you lost the ability to take out the CO2 out of the atmosphere, you're adding more greenhouse gases, in this case methane, back into the atmosphere. On the top right hand side, you can see one of the techniques of clearing the land. It's a technique called slash and burn. So slashing down the trees and burning the trees, and that's the quickest, most efficient way of getting rid of the trees. So you can see again, we're chopping down the trees, so we're not taking the CO2, and also the burning of it gives more CO2 back into the atmosphere. So there's three things going on here: losing the ability to take in the CO2, putting cattle on the land, and the deforestation, the slash and burn techniques, puts more CO2 back in the atmosphere. So three compound things going on here. Now, a huge debate at this time is there are human causes of climate change, and there are also natural causes of climate change as well. The debate is, to what extent is it human and to what extent is it natural? Now, there's evidence to suggest that the natural causes, so for example orbit change, affects the Earth's climate. About every 100,000 years, gradually, the Earth goes around the Sun, moving from a more circular motion, which is the dotted line on the top left, to a more of an elliptical, so it's got a greater eccentricity, and more of an oval kind of shape. And you can see there that if the Earth is further away, that's going to affect the climate. And that happens gradually about every 100,000 years. In addition to that, the tilt of the Earth will change as well. Now, the tilt of the Earth is what causes our seasons. At the moment, it's about 23.5 degrees. Sometimes it will be a little bit more, 24.5, sometimes a little bit less, 22.1. Now, we're talking about tens of thousands of years for this to happen, but it is a natural cause of climate change. Volcanic activity is another way that climate change happens. There's some debate about whether it actually cools the Earth or whether it actually warms the Earth in the short term or the long term, and where that happens. So huge amounts of gases and ash and sulfur dioxide come out of the volcano. Initially, it's widely accepted that initially that part of the Earth will cool because the sun's rays cannot find their way through this area of sulfur dioxide, which is a kind of really dense gas. However, once that spreads over the planet, then there's some evidence to suggest that global warming will happen, particularly in the lower area of the atmosphere, the troposphere. So in the short term, there'll be cooling, and some say in the long term, there'll be global warming. The final natural cause of climate change that we've got here is solar output. So the sun has actually got its own weather systems, and actually sometimes the sun is a little bit warmer, gives off more energy, and sometimes a little bit colder, gives off a little bit less energy. Now, when I say it's a little bit colder, that's in comparison to the sun's heat, so it's colder in terms of the sun. And you can see at the bottom, you can see there's huge fluctuations in the amount of energy received from the sun. But gradually it seems to be heating up a little bit. But there are fluctuations over time. So in the year 2000, for example, it was heading towards a peak, and then it's tailed off a little bit. And of course, this will heat our Earth up, or it will cool our Earth down a little bit. So when climate change or global warming happens, there are huge amounts of effects upon people and the environment. So the effects upon people, we're thinking about warm oceans, so more tropical storms, maybe more coastal flooding. It might be harder to grow some types of crops in certain areas because the ground's too hard, it's not wet enough. That could cause starvation or drought in certain areas. You could end up with wars between different countries over food and water supplies. Some of the impacts upon the environment. Glaciers are going to melt, the ice caps are going to melt. It's thought that that will then cause sea level rise. So low-lying countries that haven't got many mountains are going to be affected by that. Ecosystems. So on the screen here you've got the polar bear, and that's probably a most symbolic image of global warming in the Arctic. So less ice for the polar bear to get from iceberg to iceberg. Some animals and plants, they can't adapt quick enough, so then they end up dying out. In reality though, I know we've talked about people and we've talked about the environment. In the vast majority of cases, when the environment is affected, then people are then affected afterwards. So there's a symbiotic relationship here, so they kind of work together. So we're looking at managing climate change, and we're going to go through 3 mitigation strategies. Now, mitigation is to do with stopping or reducing the causes of climate change. So can we stop climate change? Can we reduce it? What can we do about it? So the first one is alternative energy production. The image of the top left, we have an offshore wind farm. So offshore wind farms, those are the ones that are in the sea. And we have onshore wind farms, and those are the ones you'll often see on mountain sites. At the bottom we've got solar panels, so you'll be familiar with those. Sometimes we whole fields full of solar panels, sometimes on people's houses. And at the top right we have a hydroelectric power station. So that's an alternative energy production. So the reservoir on the left hand side, when a little bit more electricity is needed, the gate is opened, that turns the turbine or the generator, and then electricity is produced. It ends up at the river at the bottom, or sometimes another reservoir at the bottom. That's a hydroelectric dam, and all of these are seen as more kind of green ways to produce energy. Another way to mitigate climate change is carbon capture and storage. This is where carbon dioxide is taken out of the atmosphere, often at the point of where it's released, so maybe near to industrial sites or the top of chimneys, and then it's put into solid objects and then put underground, often in the space where coal and oil and gas was taken from in the first place. It's not a common way to mitigate climate change. It's very expensive, and the technology is in its infancy at the moment. So not many places do this. There's also an argument from some groups to say we shouldn't be doing this. We should be limiting the CO2 that we put in the atmosphere first, rather than trying to take it out once we've still done the damaging techniques that we use. Another mitigation strategy is planting trees, and this is sometimes known as afforestation, which of course is the opposite of deforestation. So deforestation is chopping down the trees, afforestation is replanting or planting new trees. The idea being that trees take in carbon dioxide as part of the process of photosynthesis and give out oxygen. So the more trees that you have, the more CO2 is removed from the atmosphere. The final example of mitigating climate change is through international agreements. Now, of course, the climate of the Earth isn't limited to just countries. There's no borders on the climate. What happens in one country affects another country. So the only way to address climate change is through international agreement. So countries agreeing what they're going to do together. Each period of time, there's a COP conference. That's the Conference of Parties, Confederation of Parties. And this is the 26th time it's happened. So it happens in Glasgow in 2021. So that'll be a significant event. Probably the most significant event was the Paris Climate Agreement. Now that happened several years ago, and countries came together to say they're going to limit global temperature increase to 2 degrees. And there's all kinds of things they're going to do along those lines, reducing CO2 output, reducing the number of new fossil fuel power stations. In the UK, there's a proposal to only sell electric cars after 2030. So it's all kinds of things different countries are doing. So the Paris Climate Agreement was one of the significant ones, and each year countries come together and they see and measure how well they're doing against those targets. Okay, this section of managing climate change is all about adaptation. So climate change is going to happen, and even in the Paris Climate Agreement, it's accepted that temperatures will go up by 2 degrees, which doesn't sound like a lot, but in some countries it has major impacts in terms of how they live, sea level rise, and accessing food and water. So one of the ways to adapt people's lives is changing agricultural systems. So on the top left, you've got a range of different seeds, and it may be in the future that these seed banks, people will realise they can't grow their usual type of crop. So it's having a huge seed bank, range of different seeds, so people can choose the right type of seed that they can then grow in their particular area, maybe based on less water, maybe based on higher temperatures. In the UK, changing agricultural systems, there's now lots of vineyards, so growing grapes for UK wine. It was a very, very small industry in the past, even 10, 20 years ago. Now it's quite a wide-ranging industry, and there's lots of vineyards in the UK. So changing agricultural or farming systems is a way to adapt to climate change. It's accepted that there's going to be changes to water supply in the future, and even if the water supply amount over the course of a year remains the same, it may fluctuate at greater intervals throughout the year. So sometimes there might be more water than usual, and other times there might be less water than usual. One of the ways to adapt to changing water supplies is to install water meters. It's generally thought that if houses are at a water meter, then they're most likely to use less water, maybe turn the tap off if they're brushing their teeth, maybe take more showers instead of baths, maybe, as on the right hand side, maybe use water from water butts, where the water is taken from shed roofs or an extension roof, and use that to water plants instead of clean tap water. Now, the water that goes in the water butts, that's called grey water. It's called grey water because it's not one that you would drink, but certainly the plants don't mind if you're using water from the shed roof or the extension roof. In many places, one of the main adaptations is reducing the risk from rising sea levels. As we said earlier, one of the effects of climate change will be melting ice caps, so huge areas of maybe Greenland and Antarctica having less ice, and overall that causes the sea levels to rise. And even the warming of the sea, warm sea takes up more space than colder sea. That's called thermal expansion. So even if the ice caps didn't melt, the water would get effectively bigger anyway. So there's going to be more rising sea levels. And how do we adapt to this? And this links in with the coastal management strategy topic. So you can see on the left hand side a part of the UK where there's different types of sea defences or coastal management strategies. You've got a sea wall there, you've got the groins in the background, and also you've got the rock armour. In this case, they're man-made tetrapods. On the right hand side, in Bangladesh, the responses to rising sea level are to build storm shelters. So you can see this concrete building is built on stilts. So there's several posts holding the building up, and it's understood that underneath that the sea level will rise, the people will be above it, and they will then be safe. So there's different ways to adapt to rising sea levels. Here's all the images again, so see if you can remember which section these relate to. See if you can get the image in your head and try to remember what can you give your own story about each section here in the same way that I have during this talk. Here's the main points on the tab geography, so the absolute basics page. So the causes, the effects, mitigation, adaptation, the effects upon people, the effects upon the environment, and also reference to the Quaternary period, what's happened to the temperature.